You know, it used to be that building tech felt a lot like building a custom race car in your garage.
Oh, totally. Yeah.
Like you knew every bolt, you understood every line of code, and when you finally turned the key, I mean, you were the one behind the wheel.
Right. It was entirely within your field of vision. You built the machine and, you controlled the machine. It was a very simple one-to-one relationship.
But today, I mean, looking at the sheer velocity of the AI space right now, it feels like you've suddenly been handed the keys to an entire global fleet of autonomous vehicles.
Yeah, that's a great way to put it.
And they are like, they're driving themselves, they're upgrading themselves on the fly, and your job is no longer building the car. Your job is trying to manage the traffic without causing a global pileup.
Which is incredibly stressful.
Hmm.
We have firmly crossed the threshold here. The conversation across the industry has completely shifted from simply, building AI to the massive complex reality of managing, securing, and operating it at an enterprise scale.
And that is exactly what we are getting into today. Welcome to the deep dive.
Glad to be here.
So our mission for this session is to decrypt a massive stack of intel straight from the desk of Andrew Kagan's weekly newsletter. Random technical news you can possibly use.
Always a great read.
It really is. And it's just a massive drop of intelligence this week, covering everything from Azure and Microsoft 365 to DevOps, security, and the raw data platforms running beneath it all.
Right, we're synthesizing this across 8 specific focus areas today.
Exactly. So whether you are an IT admin keeping the lights on, a developer trying to stay relevant, or just an insanely curious tech enthusiast, this matters to you.
Because this shift to operating autonomous AI, it touches every single layer of the technology stack.
Starting with the physical, concrete, and steel where this stuff actually lives.
Yeah, the shifting foundations. So before we look at how to build and secure the future, we have to understand the physical reality of where it lives. We are moving from the industry news and trends directly into data, analytics, AI, and Azure.
And the physical foundation of the internet is fundamentally fracturing right now.
Fracturing is the perfect word. For the last decade, the default was simply choosing one of the big 3 hyperscalers and calling it a day. Right. That era is over. According to the latest industry data, the 2026 AI cloud infrastructure has split into 6 distinct categories.
I was looking at this breakdown in the newsletter, and it's wild. So you still have the traditional hyperscalers like your Azure and AWS,
Sure.
but then you have neo-clouds players like CoreWeave and Nebius. You have developer-oriented clouds, inference-optimized platforms like Grok and Sambanova, GPU marketplaces, and finally, orchestration layers sitting on top just to manage the chaos.
That's a lot to navigate.
Okay, let's unpack this because it sounds like choosing compute is no longer a simple menu. It's like choosing between buying a reliable minivan from a hyperscaler versus renting track time in a Formula One car from a neocloud.
If we connect this to the bigger picture, that analogy gets right to the heart of the compute economics. The reason this fracturing happened comes down to a massive workload shift.
Okay, what do you mean?
Well, historically, the heavy lifting in AI was training the models. But today, inference, which is the act of actually running the trained AI model in real time to get answers, that accounts for roughly 2/3 of all AI compute.
Wow, 2/3.
Yeah. And inference requires a completely different architectural profile than training. It demands ultra-low latency and highly specific chip architectures.
Which explains the sheer physical scale of what is being built right now. I mean, take Oracle's new Abilene, Texas campus. They're deploying up to 450,000 GB200 superchips in a single location.
It's staggering.
That isn't just a data center, that's a small city of pure compute. But with all these different platforms, how does an engineering team actually know where to deploy?
The guidance for platform teams now is that you must test real workloads across multiple providers.
You can't just look at a spec sheet.
Exactly.
Yeah.
You cannot rely on synthetic vendor benchmarks anymore. A generic benchmark might tell you a neocloud is faster, but when you load your highly specific proprietary dataset, the latency might spike because of how their memory architecture is configured.
Right, it's just too complex.
The performance and class variations between these 6 categories are just too wild to guess. You have to test your actual workload.
Speaking of performance, Azure is clearly feeling the heat from these neoclouds because they are dropping some massive innovations.
Oh, absolutely.
On the entry-level side, Azure SQL Database just announced a free tier of up to 10 databases for the lifetime of the subscription.
Which is huge for developers.
Not a 30-day trial. Lifetime. But what really caught my eye in the notes is what they're doing at the extreme high end. I was reading the Apollo Hospital's case study.
Oh, that's a fascinating one.
Right. They migrated to PostgreSQL on Azure, and they are now getting 90% of their clinical transactions to complete within 5 seconds.
Yep.
At their scale, dealing with millions of patient records, how is Azure actually supporting that on the back end without the database just, locking up?
They are achieving that through a new architecture called Azure Horizon DB
Yeah.
for PostgreSQL. It's currently in private preview, but to understand how it handles that Apollo workload, you have to look at the sheer allocation of resources. Horizon DB scales up to 3,072 vCores and 128 terabytes of storage.
Wait, 3,000 cores for a database?
Yes. It essentially decouples the compute layer from the storage layer to an extreme degree. That allows those thousands of cores to process queries in parallel without waiting for a traditional hard drive platter to spin, metaphorically speaking.
That makes sense.
In a clinical setting, reducing query latency from 30 seconds down to 5 seconds can quite literally be the difference between life and death when a doctor is accessing an emergency medical history.
Okay, let's unpack this, though, because whenever I hear numbers like 128 terabytes of storage being processed in seconds, I immediately think about the network.
The bottleneck, yes.
We are talking about gravity-defying amounts of data with all these massive fragmented data centers. How do we actually move and manage the storage without choking the network?
It's the critical bottleneck, and it's being addressed at the deepest levels of the operating system. First, for moving data between clouds, the new Azure Storage Mover can now migrate data directly from AWS S3 to Azure Blob using private connectivity.
So it bypasses the public internet entirely.
Exactly, which solves the bandwidth and security nightmare of cross-cloud migration. But the real game changer for latency is the new Windows NVMe of Initiator.
I saw that acronym in the newsletter, NVMe over Fabrics. What does that actually do?
So NVMe is a protocol that makes modern solid-state drives incredibly fast.
Right, like the one in my laptop.
Exactly. But historically, that speed only applied if the drive was physically plugged into the motherboard of the server you were using. If you had to access storage across a network, you had to wrap that data in older, slower networking protocols.
Which slows everything down.
It introduced massive CPU overhead and delay. NVMe over Fabrics, which is in preview for Windows Server Insiders, allows native networked NVMe storage over TCP and RDMA. Remote direct memory access. It literally allows a network card to write data directly to the memory of another computer, completely bypassing the operating system and the CPU.
Oh, wow. So you are essentially treating remote storage across a data center as if it's a lightning-fast drive plugged directly into your own machine.
Without any of the traditional networking tax.
Yeah.
When you are feeding data into 450,000 GPUs, eliminating that CPU networking tax is the only way to keep the processors from starving for data.
Incredible. So we have this fractured, high-powered, ultra-fast infrastructure, but who is actually building the software to run on it?
The builder's dilemma.
Exactly. That brings us to DevOps and the developer experience. And honestly, the rise of truly autonomous dev tools is staggering. The newsletter highlights Claude Code 2.0, and the feature set fundamentally changes what it means to write code.
It really does.
There's a new /loop command, which acts like a cron job for AI. You don't just ask the AI to write a function. You can tell it to routinely wake up, check systems, or update dependencies on its own.
The autonomy is the key differentiator here. They also added a by-the-way command, which solves a massive frustration with earlier models.
Oh, the context loss.
Right. Previously, if an AI was halfway through building a complex feature and you interjected with a new thought, it would lose the main context. Now, you can inject sidebar instructions without the agent suffering from context amnesia.
And it's not just single agents anymore. They just introduced multi-agent code review for enterprise teams.
Yeah, and that's wild.
Their AI writes the code, and a different AI, acting with a different set of instructions, reviews it. But how does this integrate with the tools developers are already using? Are we just pasting code back and forth from a chat window?
Not at all. That is where Microsoft's new Azure DevOps Remote MCP server comes in.
MCP Model Context Protocol.
Correct. It's currently in public preview, and it uses streamable HTTP transport. What that means in practice is you don't need to install a heavy, highly privileged local agent on your machine or server.
Oh.
Through streamable HTTP, your AI assistant can reach directly into Azure DevOps, read your repositories, check your Kanban boards, and interact with your deployment pipeline remotely and securely, maintaining a constant lightweight connection.
Okay, wait. I have to push back here.
Go for it.
Wait, If we have AI writing the code, AI reviewing the code, and autonomous agents running loops in the background pushing to our repos, aren't we just automating the creation of massive technical debt at the speed of light?
It is the single biggest fear of every engineering leader right now.
I mean, if an AI hallucinates a bad architectural decision, it's going to implement it before a human even finishes their coffee.
It's a highly valid concern. What's fascinating here is that Microsoft is countering this by making Microsoft Foundry Observability generally available. They aren't treating AI monitoring as a separate side project anymore.
So what does that look like in practice? How do you monitor an AI's thought process?
Tracing, evaluations, and monitoring for your AI agents are now piped directly into Azure Monitor. So if an agent hallucinates or breaks a build, you don't just see the error. You can view the exact execution path of the agent.
Oh, so you can see where it went wrong.
Exactly. You can see which tool it invoked, what context it retrieved from the database, exactly where its logic deviated from the guardrails. Also, on the data operations side, they've introduced the log analytics retry bin.
Retry bin.
Yeah, if massive batch aggregation fails because an agent pushed bad code, you don't have a permanent gap in your data. The system catches the state, allowing you to recover and rerun that specific look-back time range once the logic is fixed. It's about bringing SRE, or site reliability engineering, rigor to autonomous AI.
If you are a developer listening to this, the anxiety is probably creeping in. In an ecosystem where AI is writing, reviewing, and deploying code, where do you fit in?
Your job is changing.
It is. The answer is shifting from writing the syntax to managing the architecture. And to stay relevant while AI writes code, you need to validate your skills. The sources highlight a brand new certification meant to address exactly this. The Microsoft Certified SQL AI Developer Associate, also known as Exam DP 800.
It is a critical certification for anyone dealing with data platforms because it proves you know how to integrate these AI agents securely into enterprise databases without creating that technical debt we just talked about.
And Microsoft is clearly trying to aggressively seed the market with certified professionals because they are basically giving the beta exam away right now.
Yeah, it's a huge discount.
If you use the code DP800 Belzoni, that's DP800 Belzoni, you get 80% off. The catch is you have to be one of the first 300 people to take the beta before April 3, 2026.
And there are a few regional restrictions.
Right. The code isn't valid in Turkey, Pakistan, India, or China. But if you're eligible, it is a no-brainer to get that on your resume to prove you can handle AI data integration.
Because the people who understand how these systems are integrated are going to be the ones tasked with defending them.
Oh, absolutely.
If an AI can write a complex system at light speed, an AI can also figure out how to dismantle it. Securing the autonomous enterprise is a fundamentally different discipline than traditional cybersecurity.
Which brings us to a headline in the newsletter that is genuinely terrifying. Let's talk about the Stryker wiper attack.
Yeah, that one sent shockwaves.
This attack wiped tens of thousands of medical and enterprise devices. And unlike ransomware, which, locks your data to extort you for crypto, a wiper attack has one pure goal.
Total destruction.
Absolute, unrecoverable destruction of the data. But the kicker here is that the Stryker attack required absolutely no malware.
None. And that is why it was so devastating. Traditional antivirus or endpoint detection wouldn't necessarily catch it because the attacker didn't drop a malicious payload onto the hard drive in the traditional sense.
It's like a burglar realizing they don't need a crowbar if they can just convince the smart home system that they own the house.
Exactly. Just ask the front door to unlock itself.
Right. How does an attacker actually do that without malware?
They use a technique often called living off the land. They exploit the system's inherent rules and legitimate administrative tools. Through credential hijacking or exploiting logical loopholes in the software's architecture, they use the operating system's own built-in commands to delete the data.
Using the system against itself.
They use math and logic against the system. And this is why security validation is also becoming agentic to fight back.
Meaning the defenders have to use AI agents to hunt for these logical loopholes.
Exactly. You can't rely on a manual penetration test once a year anymore. The sources highlight Pocket Security's approach to continuous validation. You have AI agents constantly probing your own defenses 24/7, simulating these malwareless logical attacks to find the gaps before a threat actor does.
But the defense side gets even more sci-fi when we talk about the edge devices operating out in the real world. To stop data interception, encryption is literally going quantum.
This was my favorite part of the update.
The sources note that Cryptripped just integrated its BLAST protocol with NVIDIA Jetson Edge AI devices. These are the small, powerful computers running robotics, factory sensors, and autonomous drones. The BLAST protocol uses quantum entropy to generate encryption keys. But what makes this revolutionary?
It fundamentally breaks the key distribution architecture we've relied on since the 1970s.
How so?
Normally, for two devices to communicate securely, one generates an encryption key and transmits it to the other over the network.
Right.
That transmission is a massive vulnerability. If an attacker intercepts the key, the encryption is useless. The BLAST protocol leverages quantum random number generation. The two endpoints sync a baseline state and then independently generate the exact same identical encryption key at the exact same moment.
Right, really?
Yes. The key itself never crosses the network. You cannot intercept a key that was never transmitted.
That is mind-bending. Generating identical random keys purely through quantum entropy sync. And this push for absolute airtight security brings us to the reality of zero trust. We are seeing the DoD and CISA pushing incredibly strict zero trust maturity models. But there's a massive friction point when you try to apply zero trust to operational technology, or OT, like factories.
The physical reality of a factory is wildly different than an office IT network. If you are an IT admin listening to this, you know the pain of Patch Tuesday.
Oh, yeah?
You push a security update, and an office worker's laptop reboots. They get annoyed, but life goes on. Now imagine your Patch Tuesday forces a reboot on a smelting furnace, or a robotic assembly line, or a regional power grid.
Millions of dollars lost instantly, or physical danger to the workers.
The sources point out a crucial constraint. In a 5 nines environment, meaning 99.999% uptime, which is standard for critical infrastructure, you only get 20 minutes of planned downtime per year.
20 minutes, a year.
20 minutes. You can't just reboot a factory on a Tuesday. You cannot just push a zero-trust security patch and hope it doesn't break a legacy manufacturing protocol. This is why Zscaler's managed business continuity takes a really interesting approach. For these critical environments, it intentionally delays software updates by a full week.
Really? It delays them?
Yeah, to prevent a bad patch from crashing critical systems. It places the factory in a highly isolated, protected bubble, ensuring that if a bad patch is pushed globally and crashes systems, the critical factory is insulated from the update until it is proven safe.
Protecting the system from your own security updates, that is fascinating. And if we zoom in from the factory floor down to the data layer itself, the security tools are evolving to be much more programmatic.
Securing the data in Fabric is key.
Yeah, Microsoft Purview DLM, which handles data lifecycle management, just released an open-source MC key server. This allows AI agents to safely troubleshoot retention policies using read-only diagnostics.
Without giving the AI permission to actually alter the compliance records.
Yeah, exactly. And we are seeing that deep integration in Microsoft Fabric as well. Fabric now has insider risk management policies that can automatically detect if someone or something is trying to exfiltrate sensitive data directly from your enterprise lakehouses.
And to manage the sheer volume of these alerts, SOC teams are graduating beyond basic query languages.
Right. The newsletter notes that for deep analysis, Security Operations Center teams are now using Python and Pandas inside Sentinel Data Lake Jupyter notebooks, rather than just relying on Custo Query Language, or KQL. Why the shift to data science tools for security analysts?
Because a traditional query looks for something you already know is bad. But with autonomous agents and malwareless attacks, the threats are novel. By using Python and Pandas, SOC teams can run deep programmatic data science against massive security logs to find behavioral anomalies and statistical deviations that a simple KQL query would never catch.
It really is a whole new world for security. But let's bring this all down to earth.
Yeah, let's look at the end user.
We've explored the massive 128 terabyte databases, we've orchestrated the cloud, we've quantum encrypted the edge. But how does all this actually surface for the average worker sitting at their desk?
It starts with basic quality of life, but it quickly scales up to massive architectural shifts behind the scenes.
On the quality of life side, there's a great update for M365 and Power Platform. Word, Excel, and PowerPoint on the web now have a faster way to find files right from the search box in the header.
It seems small, but when you're hunting for a document during a meeting, it's a huge time saver.
Totally. But the much bigger news for the end user is the massive rollout of the Microsoft 365 E7 SKU. This new licensing tier includes Agent 365. We are moving to a world where every enterprise user has a dedicated, highly capable AI agent integrated natively into their workflow.
And the goal isn't just to give them an agent, but to teach them to build their own. The Power CCAT AI webinars are specifically teaching average users how to leverage the Power Platform and AI agents for their own productivity.
Empowering the end user. But the backend supporting that M365 experience is undergoing a massive transformation too. I noticed the changes to SharePoint in the notes.
Right. Developers can now create SharePoint sites via Microsoft Graph using a new least privileged scope called sites.create.all.
Which solves a massive security headache. Previously, if an app needed to provision a workspace, it often required incredibly broad tenant admin permissions.
Now you can grant just the exact permission needed.
Mhm.
Furthermore, SharePoint Embedded is scaling to millions of documents. This allows independent apps to build custom experiences, but store the underlying documents inside the customer's own SharePoint environment.
Meaning the third-party app automatically inherits all of the customer's Microsoft Purview compliance, retention, and security features.
Because the data never actually left the building.
Exactly. The apps are embedded securely. But while the user experience gets smoother, the format these applications use to communicate under the hood is experiencing a seismic shift.
This is wild.
This is the part of the newsletter that really stopped me in my tracks. For decades, the internet has run on JSON JavaScript object notation. If a server talks to a web browser or an API pulls data from a database, it usually passes that data as a JSON file.
Right.
But the sources highlight a massive shift away from JSON towards something called TOON, token-oriented object notation.
Yep, the format shift.
Now here's where it gets really interesting, I have to ask. We've used JSON forever, specifically because humans can read it. A developer can open a JSON file, read the text, and understand exactly what data is being passed. Why would we suddenly change the fundamental language of the web?
Because JSON is far too verbose for AI, and AI models don't read text the way we do. They process tokens.
Okay.
And in the world of AI, tokens equal compute, and compute equals money. Think of it this way. JSON is like writing a highly detailed, grammatically perfect letter, putting it in an envelope, and sealing it with wax, just so a human can read it comfortably. TOON is like sending a tightly encrypted burst of Morse code. The machine doesn't care about grammar, white space, or readable brackets. It just wants the data instantly. TOON reduces token overhead, making serverless AI APIs cheaper and faster. The AI doesn't need human readable, it needs efficiency.
So every character, every space, every curly bracket in a JSON file consumes a token.
Yes. Up to 40% of the tokens in a JSON payload might just be formatting syntax. TOON strips away all of that human readability to drastically reduce the token overhead.
Wow. So to save on compute costs, we're literally restructuring the foundational data format of the internet to better suit the machines because translating it for humans is just too expensive.
That is the reality of operating in an autonomous scale.
Let's take a breath and recap the incredible scope of today's deep dive into Andrew Kagan's newsletter.
It's been a lot.
We started by looking at the physical fracturing of the cloud, the shift towards specialized neoclouds and inference platforms. We explored how Azure is pushing boundaries with 3,000 core Horizon DB architectures to deliver 5-second clinical database queries, and how NVMe over Fabrics is bypassing CPU bottlenecks.
Then we looked at the builders.
Right, how developers are wrestling with autonomous tools like Claude Code 2.0 and fighting AI-generated technical debt with deep Foundry observability. We covered the terrifying reality of malwareless wiper attacks and how defenders are fighting back with continuous agentic validation and quantum-encrypted edge devices.
All the way down to Agent 365 and OneDrive for the end user.
And finally, realizing the very language of the web is shifting from JSON to TOON.
It is a staggering amount of change, but it all points in one clear direction. And it brings us back to where we started today. If you think about that metaphor of managing a global fleet of autonomous vehicles, consider the implications of TOON. If our enterprise systems are shifting to TOON, a language optimized purely for AI agents to speak to other AI agents, intentionally bypassing human readability to save tokens, at what point does the enterprise network become a conversation we can no longer comprehend, even as we orchestrate it?
That is a brilliant and slightly haunting thought to leave off on. We are building the roads, but we don't speak the language of the cars driving on them anymore. Thank you so much for joining us on this deep dive. Keep questioning, stay curious, and keep learning. We'll catch you next time.